So today I really want to focus on polynomial long division, and it's very related to the tabular method for polynomial multiplication. Notice here that in this diagram we've got a division problem, and then I've actually already given you the answer here, so this would be the answer portion, but I wanted to show this whole thing to you because I want you to see how this builds up. So the first thing we should probably do is take the things that we already know. So we know that this is something that we're dividing by, and that's not part of our answer. So we're going to go ahead and put it off in the field over here. So we've got 2x and positive 5, and that will go over there. Now everything on the numerator here, or the top of this fraction, is actually what goes into the diagonals along here. And so this 2x to the third is going to go to that first top diagonal. And so I'm going to put it out there. It goes in there diagonally as 2x to the third power. And then in this diagonal, we get that 15x squared. 15x squared. And then this diagonal, we get that 27x. And then in this diagonal, we get the 5. Now I want you to notice here that for this 2x to the third, this is the only cell, this is the only box that it goes to. Whereas for this 15x squared, that is shared between this box and this box. And with multiplication, when we added those boxes together, we got that answer. And here we're going backwards, and it's being shared among those two. Same thing with the 27x. It is shared between those two cells, and then this 5 box only goes there. So with that in knowledge, everything in black currently is what we are given as a part of the problem. I'm going to change the color to red for the things that we have to figure out on our own. So I look here and I see, oh, there's only one box. I like to start up here, and you'll see why when we start doing long division and we get remainders. Right now we won't have any remainders. But that 2x to the third, this is the only box that it can go in. This is the only box that it can go in. And so I start to think, okay, this is the only thing that goes in there. Well, 2x times something got me 2x to the third. Well, looks to me like that's gotta be x squared, because x squared times 2x squared, x squared times 2x gives me 2x to the power of 3. Okay, this is really a good place to be. From here I can start to think, oh man, I have this and I have this. Oh, I can figure out what goes in that box. That box has to be x squared times 5, which I know to be 5x squared. This is where it gets a little bit tricky, I think, is that I have to remember I'm having a really hard time figuring anything out, but I know that this square plus this square is equal to that 15x squared. So if that's 5x squares, and I need 15x squares, that's got to be 10x squares. So I've got 10x squared. And now I can kind of redo this process. I see 2x times something gives me 10x squared. Well, the coefficient's got to be 5. And then x times x is x squared. Oh, there we go. There's my 5x. And then now I can figure out this bottom cell on the bottom. 5x times 5 is 25x. What plus 25 equals 27? I use my diagonal now. Oh, well, 25 plus 2. Oh, 2. It's got to be a 2x there. Oh, well, what times 2x gives me 2x? That's got to be a 1. And here's my box. This last box I'm going to use in green because I know that this is my checks box. I got the 5 by doing 1 times 5 and 5 because it's the only thing that goes in this diagonal cell. So here's a quick, just to check. Remember that the stuff up here goes around the outside. The denominator, the thing I'm dividing by, should go off on the right side, and I'll go ahead and add that in real quick. X, and then it's a -2, so we got to put that there. And then all of the stuff on the inside we can figure out. I like to start with this corner box, 2x squared. I can determine, oh, what times x? What times x gave me 2x squared? That's got to be a 2x. So I've got 2x, which means that I can figure out this is a -4x. And a lot of people get confused at this stage because something -4 is x. Well, that something's got to be bigger than 4. So I'm going to just kind of guess 5x minus 4x. Oh yeah, that's 1x because there's an invisible 1 right there. Great, that works. Something times x gave me 5x. That's got to be, what is that, a 5? Check it with a 5. That's got to be -10. Oh, yep, that's -10. Perfect. I've checked myself. And my answer to this math problem is this. This is my answer. And so I'm going to want to rewrite that so that when I have my division problem, my answer to this division problem is 2x plus 5. We'll quickly set this up. This guy is going to make our own boxes. I know that the denominator has 3 terms, so I'm going to make a box that has 3 spaces, the 4x squared, the 12x, and the 9. And then I'm going to start going around. I think we only need 3 boxes here, but I could be wrong. So I know in there goes 8x cubed, and that diagonal is 36x squared, 54x, and 27. It looks like I don't need anything over here, so I'm going to just go ahead and erase all of that. I don't need any of it, right? Reconstitute that side, that 4x squared, 12x, and 9, and clean this up just a little bit. All right, so now that I've got my setup going, I'm going to start again in this top right corner, 8x cubed. Something times 4x squared, so I know 2 times 4 is 8. X times x squared is x cubed. So now I get to fill in the rest of this whole row. I get to fill the rest of this in for absolute free. So 2x times 12x is 24x squared. 2x times 9 is 18x. Beautiful. And then I'm going to take advantage of these diagonals. So something plus 24 is 36. That's got to be 12. That's got to be 12x squared. And so I think something times 4x squared gave me 12x squared. Oh, that's the only thing it can be is 3. So 3 times 4x is 12x squared. And then I can use these last 2 boxes to check myself. I can use this box to check, and I can use this box to check. And we'll do that really quickly. So 3 times 12 is 36x, and 36 plus 18 is 54. Okay, there's my check. 3 times 9 is 27, and there's another check. I got it. I got it correct. So I just want to give us some practice. I think the hardest thing is knowing how to build out these cells. I like to start with doing however many's on the denominator. So there's 2. It's a there's only going to be 2 terms if I replace all the place values. I've got x and 5, and then I can start going around with the numerator, knowing that that goes 2x cubed, knowing that is 11x squared. I know that that's going to be 7x, and then last but not least is 10, and that's just gonna go there. So even though it doesn't look beautiful, it's the stuff that I have and I know that this is the right cell. I could clean it up if I wanted to, and maybe with some time you'll develop some strategies for figuring out how many boxes you need. But for now, this is okay. So this 2x cubed is where I start. I know that 2x squared times x is 2x cubed, so that I can fill in this bottom. So 10x squared to make 11 is 10 plus x squared. So I need an x up here. That makes it 5x. 7x plus is equal to 5x plus 2x. So that makes this top part have to be a 2. 2 times 5 is 10, and 10 is my check. So the answer to this multiple division problem has got to be 2x squared plus x plus 2. And this is my answer. I have to somehow distinguish that that is my answer.